Okay, now this is a square root, so I'm looking for factors alike that are 2 in pairs inside. So what I have is I have 4 times 4 times 3 gives me 52. So I have 2 factors of 4. My index is 2. I bring one of them outside and I leave what's left over inside. So we have 4 root 3 for this problem. When you have a fraction inside of a root sign, you can actually take the radical and split it up into root 8 divided by root 9, which is the square root of 8 is 8 is 4 times 2, or 2 cubed. So I have 2 times 4, and 4 has 2 factors of 2, one of which will be able to come out. The square root of 9 is just 3. Again, we're talking about the principal square roots. So this 4 brings a 2 out, and I have 2 root 2 over 3. And that's the final answer for this. Now remember, these are only in simplified form as long as there is no radical on the denominator, so no square root or cube root down here, and every thing that is left in a square root sign or a cube root sign cannot have any more factors brought out of it. This one's already split up for you into the square root of 270 over square root of 6. Now, if you want to, you can think of this just like we can split them up if they're in one fraction. You could actually, if that were divisible by 6, and it is, we could actually rewrite this as the square root of 270 over 6. And now 270 divided by 6, if you can do the division, it's 35. So we have the square root of 35. That's 270 divided by 6. Well, the square root of 35, now we have to take this and factor this. I can't really do the square root of 35 because there's no numbers. I have 7 times 5 gives me 35. Well, both 7 and 5 are both prime numbers. And I don't have 2 factors alike, and my index is 2, so I cannot take out anything. So I'm actually done when I get to the square root of 35. Now my index here is 3, so I'm taking the cubed root of this, which means I have to have 3 exactly alike factors inside of the cubed root sign to bring out one of them. So this is equal to, if I have, you could say this is 25 times 10, but I really need 3 factors alike. So if I have 5 times 5, which is the 25, times 5 times 2, you can see the entire factoring in here is I have 3 of these, which matches my index of 3. So since I have 3, and I'm taking the cube root, I bring one of them out and leave what's left in. Remember, when one of them comes out, I just have 1. So 5 root 2 is the answer to this. When you're squaring something inside of parentheses, the whole thing gets squared. So just like with all your variables and when we had variables and we were squaring them, you're squaring everything inside. So 2 squared and root 7 squared. Well, root 7 times root 7 is just root 49, which is the same as, let me write it down here, root 7 times root 7 is root 7 squared, is root 7 times 7. Well, I have 2 factors of 7. My index is 2. This is equal to 7. Okay. You also had a law that said that the square root of this of something squared is equal to something. In other words, the square root of a squared equals a. You had a law that said that. Now, to simplify this one up here further, we have 4, and that's 7, times 7 is 28. Okay, the square root is of 32. Factor what's inside. I have 32 is 16 times 2, which is 4 times 4 times 2. The index is 2. I'm looking for 2 factors. I bring the 4 out, and I have to leave the 2 inside. So 4 root 2 is how this one's done. Now with an index of 3, I have to have 3 factors alike in here. Well, we already found out that this was 4 times 4, which is really 2 times 2 times 2 times 2, 16 times 2. And we're taking the cubed root, so for every 3 factors alike inside of here, I can bring out 1. So I get 2 outside times the cubed root of whatever's left inside. Well, I have 2 left over inside, so I have 2 times 2, which is 4. So 2 times the cubed root of 4 is the answer to this problem. Again, our index now at this time is 4. So I'm going to break this up into our 2 times 2, 16 times 2 is 32. And I'm looking for 4 things exactly alike in here to bring out 1. Again, that's the 4th root. I forget to write that out there. So I'm going to bring out 1, 2, and I have left the 4th root of 2 left. Now as you can see, before when I had 4 of them, there really were 5 2's in here. That's 32. And since my index is 5, I bring 1 outside, and the 5th root of 32 is just simply 2. Okay, in this particular problem, since I can't do the division first, I'm going to split these two up. The root x squared and the root of y cubed. Now, if I apply this rule, n is even here. It's 2 and 2. So this is equal to the square root of x squared is equal to the absolute value of x. Now down here I have the square root of y cubed. So I can bring out a y, and I'm left with a square root of y left, because there was 3 factors of y in here. So I brought 2 out as a y outside, and I leave 1 in. Now we have to do what's called rationalize the denominator. The only way of getting rid of that radical in the denominator is multiplying it by root y. Because I do have the law that says root a times root a is equal to a. So I'm going to use this rule right now, and I'm going to change this fraction. And it's nothing more than your normal fractions. You know what I do is root y over root y is equal to 1. So I'm not changing the value. I'm going to an equivalent fraction. And so now I have the absolute value of x times root of y all over. Now I have y squared times, or y times y is y squared. Remember, using this, I'll have y when I multiply these two times another y is y squared. And so this is the way you need to leave these. You can never leave a radical in the denominator. Now just how I took the other things inside, when they were just numbers, what did I do? I factored them first, right? So I'm looking for 2 factors exactly alike. Well, I still have to factor what's inside of here. I have, let's take out the greatest common monomial, and I have 2 times a squared plus 2a plus 1. Well, now this is a perfect square. You should recognize this, and if you don't, it's root 2 times a plus 1 quantity square. Well, now I have 2 factors exactly alike. I can bring one of them out. Because I have a variable, though, I have to make sure that I bring it out as an absolute value of a plus 1, because also this is even and this is even. My index is even and my square in here, times the square root of 2. And I'm done. And when you bring something out, it always comes in front of the square root sign. You don't ever put anything behind the square root sign as far as variables or anything when you bring them out, because as careless as some people are at drawing their square root signs, you don't really know where it ends. If you're not careful, you might think that something's still inside the square root sign. So that's why we always bring things out in front of the square root sign, even all the variables. And the only thing that's left is what's left inside.